Hi students, MCQ number 13. The diameter of a gas molecule is 2.4 into 10 power minus 10 meter. The mean free path of the gas molecule at normal temperature and pressure has to be determined. The value of Boltzmann constant is given as K equal to 1.38 into 10 power minus 3 joule per Kelvin. This is a different type of problem. We have derived an expression for the mean free path, is it not? What is mean free path? It is the average distance travelled by a gas molecule between any two successive collisions. And the mean free path is denoted by the symbol lambda. This is a symbol for mean free path. So this is now equal to 1 divided by square root of 2 into small n into pi d square. What is d is the diameter of the gas molecule, which is given as 2.4 into 10 power minus 10 meter. Okay. Then what is n? N means what? Number of molecules per unit volume. That is equal to what? A total number. See here, small n is equal to total number of molecules divided by the volume of the container. Understood? So I am going to substitute here. So this is now equal to 1 divided by square root of 2 into capital N by V into pi d square. Am I right? Small n is substituted by capital N by V. Once again, from the ideal gas equation, PV is equal to NKT. PV is equal to NKT, or V is equal to NKT divided by P. Okay? So from the ideal gas equation, the volume can be substituted. V can be substituted by what? NKT by P. So this is once again equal to 1 divided by square root of 2 multiplied by N divided by, instead of V, what I am going to substitute is NKT by P. So this is NKT divided by P into pi d square. So this N and N get cancelled, and this KT will go to the numerator. So this is now equal to K into T divided by square root of 2 into pi d square into P. This is the final expression. In your textbook also, the derivation is one step they must have given here. The derivations should have stopped here. Then after substitution, it can also be expressed in terms of temperature and pressure from the ideal gas equation. So both these two expressions you must have derived in your theory class. So this is required for me in terms of temperature and pressure, because the NTP pressure and temperature we know it, is it not? So I will write here at normal temperature and pressure. Okay, at normal temperature and pressure, P is equal to 1.01 into 10 to the power of 5 Newton per meter square, and the temperature is equal to 0 degrees Celsius, and that is equal to 273 Kelvin. That is indirectly given. We must remember, they won't give the values. We must remember. Then what else are given? K. The value of K is given. K is equal to what? Boltzmann constant, 1.38 into 10 to the power of minus 23 joule per Kelvin. What else is given? Diameter. So diameter is equal to 2.4 into 10 to the power of minus 10 meter. So K, diameter D, pressure P, and temperature T, all are given. We have to substitute and we have to use the calculator and do the calculation, that's all. So now lambda is equal to K. K is 1.38 into 10 to the power of minus 23 into temperature T, 273 K, divided by square root of 2. Square root of 2 is what? 1.414. So 1.414 into pi value is 3.14 into d square. D square is what? 2.4 into 10 power minus 10 whole square. So 2.4 into 10 power minus 10 the whole square into pressure. So into 1.01 into 10 to the power of 5. Now all these numbers we can group together and 10 powers separately we can write, isn't it? So this is now equal to, so this is also equal to 1.38 into 273 divided by 1.414. So 1.414 into 3.14 into 2.4 the whole square. So 2.4 into 2.4 we have to calculate now. 2.4 whole square. So this is 5.76. 5.76 into 1.01. Okay. Now here you see 10 power minus 23. Here 10 power minus 10 the whole square will become what? 10 power minus 20. Here 10 power minus 20 and here is 10 power plus 5. So when you add these two it will become 10 power minus 15. So when this is coming up as 10 power plus 15, then into 10 power minus 8 will be remaining. Okay, so this is 23, here 15. So when it is coming up it will become minus 8. So now we have to find out the calculation of this. See here 1.38. So 1.38 into 273 into 273. So this is 376.74 into 10 to the power of minus 8 is in the numerator divided by denominator is root 2. 1.414 into pi value is 3.14 into 5.76 5.76 into 1.01. So this is 25.83. 25.83. So we have to find the value of this fraction 376. 376.74. So this is to be divided by 25.83. So this is coming as 14.58. So 14.58 into 10 to the power of minus 8 meter. Now to adjust the powers I can shift this decimal to the left. Okay, I can shift this decimal to the left and reduce the power. So this also can be written as 1.458 into 10 to the power of minus 7 meter. Now we can round up the digits. 0.458. Okay, after 4 this 5 can be taken as 6 because here all answers contain the digit 6. Now I can round off. 1.458 can be written as 1.46. Therefore lambda is now equal to 1.46 into 10 to the power of minus 7 meter. So this is how we have determined the value of what? Lambda, that is the mean free path. So which of the option is correct? 1.46 into 10 power minus 7. The first option itself is the correct answer. Therefore option A is the correct answer. See, such numerical problems and all will consume more time, nearly 2 minutes or more than 2 minutes also it may take. And also if you go wrongly, again and again you should not check the value. So we have not got the correct answer like that. Please keep such problems at the end. So in the NEET and JEE, when you attend all the questions, no, whichever is directly visible, the answer by elimination method, by substitution method, by formula, remembering, like that, some questions will be there. That you have to attempt first. Then some easy calculations which we have done in the previous problems. Like that you can go first. When such problems are meeting you, means you leave them in the first round. Okay, you skip this and go to the other questions. Finally, if you have time, means you attempt. Otherwise, you have to skip only because it will consume much time. Okay. Anyhow, if you practice again and again means you will get in which range the answer will come and you will be successful. I hope you must have understood well. Fine.